Hello and welcome to the next episode of my Learn With Me Opsix series. So far we've spent some time looking at the basic features of the synthesizer, listening to the sounds of the different waveforms on the operators, listening to the different operator functions that are available, experimenting with the mod matrix and making a subtractive synth. So today what I'd like to do is start doing some actual FM sound design. And the way that I'm going to do that is today I'm going to talk about building a 4-operator FM sound. Now this is a 6-operator synthesizer, but I think it's easier to build these things up incrementally. So I'm going to start with 4 operators, and more than that, I'm going to start with 1 operator, add a second, add a third, add a fourth. If I have time, I'll make a second 4-operator sound, but it may already be the end of the video, so we shall see. So the first thing to think about when designing a sound like this is what algorithm we're going to use. So let's initialize. So you might ask, well, firstly, what is an algorithm? Now this isn't a tutorial on FM synthesis. I have a whole other video series on that, but just to give you a quick flavor for it, this diagram here is an algorithm, and it contains blocks numbered 1 through 6. Those represent the 6 operators over here, and an operator has some features, including an oscillator. By default in FM synthesis, an oscillator is a sine wave, so you see it says sine there. It can be other waveforms on this synthesizer. Secondly, operators may output to the mixer, or they may not output to the mixer. When they output to the mixer, we call them a carrier. The way this diagram works is signal flow is top to bottom. The bottom row are the operators that are connected to the mixer, so we can see operators 1 and 3 are connected to the mixer. They are carriers, and they have a corresponding color on this diagram. Operators 2, 4, 5, and 6 are not connected to the mixer, so we call them modulators. Why do we call them modulators? Because they modulate other sounds. You may also notice a little curve at the top of operator 6. That is feedback. So if we jump over here, we have a property called algorithm feedback. So any feedback loop you see like that at the algorithm level is controlled through this algorithm feedback parameter. Anyway, back to this display. So you can think about then the carriers as the things on the bottom row, and those are the things which are outputting the sound. If you wish, you can imagine those as different, potentially independent sounds which can be output, or layers of the sound. So an example I've used in the past is, let's think about a piano sound. One of the elements of the piano sound might be the hammer thud. So that's one. Another one might be the initial main bell-like tone that you get on a piano. And the final one might be the slow decaying string release. So for a piano, I might choose something with 3 carriers. Since I'm only going to be using 4 operators here, I'm going to go for something which has 2 carriers. So therefore, 2 modulators. So I'm going to scroll through. This first one has 2. Sorry, wrong dial. And that one has 2. Also 2. This has 3, 2. So I think the simplest to use is probably going to be this one. So what I'm going to do is the operators I don't want to use for now, I'm going to mute them. So I'm not going to use the 2 on the end. So I'm going to turn them to mute. So now you can see I only have these 4 operators available to me. 1, which is modulated by 2, and 3, which is modulated by 4. But for now, I'm only going to use operator 1. And this is the tuning. So 1 means it is tuned with the note I press. And currently it's a sine wave, and I think that's okay. Let's think about the type of sound that I'm going to make here. What I might do is I might use one of the carriers to make a sort of longer, maybe pad-like sound with a long decay and a long release. And the other one I'm going to use to make a pluck sound, which is going to be more of an accent at the beginning of the sound. I'm not imagining a piano, I'm imagining a sort of synthetic sound here, but let's start there. So if this is going to be our more pad-like body, first thing I think of is I want to soften the attack a bit. Oops, wrong operator. On. So I don't want it too soft, just softened a little. Next, I want it to have quite long decay. A reasonably long release. Okay, so I think that's a good starting point for this. Now I'm going to come up with a sound that's going to modulate this to add a little bit of variation so the tone evolves. So this is going to be operator 2. Looking back at the algorithm, 2 is above 1. In other words, operator 2 modulates operator 1. So let's go to operator 2 and let me just turn it up for now. Now let's try tuning it. So this is the lowest possible. So this is now tuned to 3 times the pitch of the note that I press. So now I'm going to adjust the envelope shape here, and I want it to also have a delayed onset, so I think that maybe 3/4 of a second can decay over a couple of seconds, have maybe a half-second release, and it can go down to almost 0. So similar envelope shape to 1. So I think at the moment this is too bright, so I'm going to turn this down. So now I have a 2 operator sound. Now it's actually an FM sound. In the first case it wasn't really an FM sound because there was no frequency modulation. I'm now going to introduce a 3rd operator, and this is going to be the beginning of the sort of plucky sound that I was talking about. So first, I know for sure I'm going to want a plucky shaped envelope. So let's make it half a second long. Maybe a little longer. I set the curve to exponential. That means the decay is more rapid. I think for simulating an acoustic sort of sound, like something being struck, that rapid decay is quite believable. So let's make the release a little longer. Sounds good. So now let's try and modulate that. So let's turn, I'm going to turn operator 1, I'm going to mute it temporarily, just so I can hear. I quite like that sound, it's quite unusual. So this one is tuned up. Let's look at pitch. So operator 3 is tuned at 5 times the pitch of the note that I play, and operator 4 is now tuned at half the pitch of the note that I play. So now, operator 4, I'm going to give it an envelope shape. So similar. So now let's unmute operator 1. Back to FM mode. So now I'm thinking of velocity sensitivity. So what I think I'm going to do here is I'm going to make operator 4, which is changing and sort of enhancing the timbre of operator 3, quite velocity sensitive. So operator 4, I'm going to make, say, 75% velocity sensitive. That means that it will go down, it will begin at 25% of the volume that I've set it to, and it will go up to the level that I set. So in other words, 75% of the level is velocity sensitive. If I set it to 0, none of the level is velocity sensitive. So adding velocity sensitivity will make it quieter at low velocities, and this will be what you hear at full velocity. So I'm going to do the same for operator 3, and probably to a lower degree. So I gave that 75%. This one might be 50% velocity sensitive. Okay, and now operator 1 and 2, I'm going to do a similar velocity sensitive thing. I think operator 2 can maybe also be 50% velocity sensitive, which is the timbral adjustment of operator 1, and operator 1 I'm going to make less velocity sensitive. So in other words, this is going to stay quite loud. This is going to become a bit quieter at low velocity. So at low velocity, high velocity, okay, so now let's get into the mod matrix here. I'm reasonably happy with that sound. As I said, I was looking for something synthetic. I wasn't really looking for an acoustic sound. So what might I want to do? Well, I think the first thing I'd like to do is have the mod wheel do something interesting. In fact, let's add a filter first. So let's try the Poly 6 filter. So let's So I want to set the cutoff such that I can hear it cutting the sound. And now let's bring the envelope in, and let's have the envelope modulated by the mod wheel. So you can hear that the sound is getting brighter, but the brightness is actually the degree to which the filter is affecting the sound. So let me extend that out a bit to maybe 7.5 seconds, 3 seconds here. So I've actually decided that I would like this first voice to be a little more velocity sensitive, and this second part of it, the second layer, to be a little less velocity sensitive. So this I set to 25, so I'm going to put these two at, let's say, 50 and 60, and these two at 40 and 50. Let's just listen to how that sounds. Overall, the sound's getting a bit quiet, so I'm going to go into the miscellaneous settings and I can increase the level of the sound. Okay, I'm quite liking the way that sounds. I like the I like the way the velocity sensitivity works. It could do with a little more character. Character, I don't want to spend too much more time, so let me think about add a little bit of chorus, and then as we turn the modulation up, the mod wheel up, let's bring in more chorus. So mod wheel, destination, chorus mix. So let's look at these master settings here. Of reverb. So I think I would like more reverb when the mod wheel comes up as well. So let's do that. Control mod wheel to reverb level. So I feel like I'd like more filter in that high end. So in filter modulation, I can turn the filter down at the high end of the keyboard. Low register. So LFO2, let's listen to that. Okay, so I had a general feel for the sound that I wanted. I deviated from that towards the end, but hopefully I demonstrated a sort of model for how I might construct an FM sound. I started with a concept of what I wanted. I picked an algorithm that I thought could realize that concept, and I built the sound an operator at a time. Now in this case I did operator 1, a carrier, and then I did its modulator. More commonly I would do all the carriers first, and then I would build the modulators on those and build the modulators on those. But I think this worked because I had a concept of where I wanted to go. Note that these high-level parameters that I adjusted they let me adjust all of the attacks or all of the decays and releases at once, so I can change the overall shape without digging into each of the operators. So I think this went to show what I wanted to show with respect to how I might approach designing an FM sound. I think I might do... I think I'm not going to do another 4-operator FM example here. I think I'd like to focus on some of the more unusual features. So probably my next episode is going to be designing a 6 operator sound, following a similar model, but hopefully proceeding a little more quickly. And hopefully that will be illustrative of the process that I follow, and it will then allow us to better understand the synthesizer and how we move forward from there. So, I hope this episode has been useful to you. I hope you'll join me for some more episodes in this series. But in any case, most importantly, I'd like to say thank you very much for watching, and goodbye.